Hello friends, welcome back to my YouTube channel. This is Pandana K. Today I am going to discuss a topic that comes under the subject Automata Theory and Compiler Design. Now let's see the topic Minimization of DFA. Under this, let's study definition of it, algorithm used to solve this problem, and let's solve one example problem. First, let's see definition of minimization of DFA. Two states P and Q of DFA are equivalent if and only if transition of P, W and transition of Q, W are leading to a final state, or transition of P, W and transition of Q, W are leading to a non-final state. Definition of minimization of DFA states that is P and Q, there are two states. If one state is of final state and another state is of non-final state, if these two conditions satisfy, then we can minimize the DFA. Let's see an algorithm to solve this problem. To find the equivalence of DFA, we can use table filling algorithm. Let's see step by step. The first step is remove all the non-reachable states from the start state. Second step is for each pair P and Q where P belongs to Q and Q belongs to Q, if P belongs to final state and Q doesn't belongs to final state, or P doesn't belongs to final state and Q belongs to final state, then we can mark P and Q as X in the table. That is, if P and Q are present in the DFA and either of these states, one should be of final state and another should be of non-final state. If these two conditions get satisfied, then we can mark P and Q in the table as X. For each pair P and Q, find transition of P and Q is equals to R, and transition of P and Q and A is equals to S. If the pair R and S is marked in the table, then we can mark the pair P and Q. Repeat the step 3 until no marking can be made. Combine unmarked states. Let's see an example problem for this. As per the step 1, remove non-reachable states from the start state, that is, remove Q3 because it can't be reached from the Q0. Here, our starting state is Q0. This is our starting state. From starting state, we should reach all the states. So let's see we can reach or not. Q0, from Q0, Q1 can be reached. From Q1, from Q0, Q1 can be reached. From Q1, Q2 can be reached. So from Q0, Q1 and Q2 can be reached. Now let's see Q3 can be reached or not. Q3 cannot be reached because it doesn't have any input states. So Q3 can't be reached. So we should remove Q3 from the DFA. As per the algorithm, as per the step 1, we should remove Q3. After removing the Q3, this is the diagram that we got. Now let's see step 2. As per the step 2, we should draw a table like this and mark X where P and Q contains one final and one non-final state. If that's so, mark P and Q as X, that is P is a final and Q is non-final. As per the step 2, if there are two states, that is P and Q, one should be of final and another should be of non-final. If these two conditions satisfied, then we can mark as X in the table. Now let's see in this example problem. Here Q1 and Q2, these both are final state, which is marked as star. Here in the diagram, final states are represented as double circle. Here Q1 and Q2 are both final states, so we mark as star in the table, and in the diagram we mark it as double circle to represent it as final state. First, let's take Q1 and Q0. Here, Q1 is a final state and Q0 is a final state. So we can mark it as X because one is a final state and another one is a non-final state. So we can mark as X. Next, let's take Q2 and Q0. Here Q2 is of final state and Q0 is of non-final state. Here Q2 is of final state, Q0 is of non-final state. So we can mark as X because condition is satisfied. Now let's see Q1 and Q2. Q1 and Q2. Here these two states are final states. So we can't mark it as X because one should be of final, another should be of non-final. Here the condition is not satisfied because both are also final states. So we can't mark it as X in the table. Now let's see step 3. As per the algorithm, the step 3 states that Q1 and Q2 is not marked, then Q1 and Q2 can't be marked in the table. If Q1 and Q2 is marked, then Q1 and Q2 can be marked in the table. That is, we should draw a table like this, and we have to check Q1 and Q2 with respect to A and B, to which state it is reaching. So in the table which is not marked, that is Q1 and Q2 states are not marked. So we should take this states, and we should check with respect to A and with respect to B. That is Q1 with respect to A, where it is reaching Q1 with respect to A. It is reaching to Q2. So Q2, and Q2 with respect to A. Q2 with respect to A, where it is reaching, that is Q1. So Q2 comma Q1. This is the state we got with respect to A. And let's check with respect to B. Q1 with respect to B, that is Q1 is reaching where with respect to B, that is it is a self loop. So Q1 is reaching to Q1 itself with respect to B, and Q2 with respect to B, where it is reaching Q2 with respect to B, that is self loop. So Q2 is reaching with respect to B to Q2 itself. So these are the states that we got. We should check in the table if these states are marked, that is Q2 and Q1 and Q1 and Q2. If these states are marked, then we should mark as X in the table. But these states are not marked in this table. So we can't mark Q2 and Q1. Without doing this step, we can directly say that Q1 and Q2 can't be marked because both are of the final stage. So this, if both are also final stage, we can't mark as X in the table. So now let's see step 4. Repeat the step 3 until no more marking can be done. As per the example, there is no marking can be done, so we'll stop there. Now let's get into this step 5. Combine the unmarked states. Here the unmarked states are Q1 and Q2. So we should combine these two states. After combining these two states, this is the final DFA we are going to get. Now let's compare these two diagrams. Q naught is having the self loop B, so there is no change. We write it as same. That is Q naught is having the self loop B, and Q naught is going to Q1 with the state with respect to A. So we mark it. So Q1 and Q2 are combined together. That is Q1 and Q2 is of one state now, and we mark it as double circle because both are also a final state. And Q1 is going to Q2 with respect to A, and Q2 is going to Q1 with respect to A. So we mark it as self loop because both are of one state now. And Q1 is having a self loop B, and Q2 is also having a self loop B. So we take the self loop A comma B. Thank you.